Hello, ladies and gentlemen. Let's talk about the unit circle. Okay, you had two jobs. You were to fill out and complete a unit circle. This is what it should look like. I know that I've had you do this more than one time, and that can be kind of annoying, and especially when you guys did yours so color coded and everything. But we've got to get this information memorized, and so repetition definitely helps. And so just again, as we're looking at this, I've got all of the angles with in degrees and in radians all the way around. I've got the coordinates at every intersection spot all the way around, and we keep seeing the repetition of the exact same numbers. We start with 0, go to 1/2, square root of 2 over 2, square root of 3 over 2, and it maxes out at 1. And then those same numbers go back down. Square root of 3 over 2, square root of 2 over 2, 1/2, and down to 0. And then we just see the negative version of those same numbers. And the x and y's, and we see them kind of switch spots and stuff like that. And so I'm just trying to help. I want you to think, remember that square root of 3 over 2 is going to be the biggest number you see besides 1. So when I think about the x going out really far, it's going out to square root of 3 over 2. That's going to be that angle above 0, that 30-degree angle, or pi over 6, that reaches way out. When I think about something really steep, it's coming way up, and that's about how high it went. It goes that height, that y value, square root of 3 over 2, but it doesn't go out very far. So how far it went out is only 1/2. There's all sorts of ways of looking at this. Another thing I just want to point out real quick is a long time ago we did talk about how 45-degree angles were really neat because they go out as much as they go up. And we see that in their coordinates, the square root of 2 over 2 and square root of 2 over 2. The other thing I want us to remember, though, is if they go up as much as they go out, then this has a slope of 1. And we said that tangent theta was equal to slope. So this thing has a slope of 1. This one is steeper, so it must have a slope bigger than 1. This one is not as steep, so it must have a slope less than 1. And then the other 45-degree angles back here, this would have a slope of -1. This one is steeper, so it's got a slope of negative and then a number bigger than 1. And then this one's less steep, so it has a negative slope, but a slope that's not quite -1. It's going to be maybe a smaller number, a fraction actually. All right, now let's talk about so this was the hope that you were going to be able to get this at the very least filled out. Now this second part, I know that you might not have understood, and that's okay, because you're going to get another shot at it. But I want to at least try to explain it right now, so I'm going to keep bouncing back and forth. Let's look at this first instance. It says sine theta is 1/2, and your job was to write theta in two ways. It said theta equals, and then there was another one over here that said theta equals. Okay, and with those, what you were supposed to do is you were supposed to write what theta equals in degrees between 0 and 360, and in radians between 0 and 2 pi. All right, looks like I missed a couple dashes on that, but that's all right. And so that was your job. Your job was to tell me what theta is in both degrees and in radians. All right, so what does it mean to say sine theta is 1/2? Well, we know back from chapter 1 that sine theta is equal to y over r. And we know, because this is the unit circle, that r equals 1. So therefore, sine theta is y over 1, which is just y. So what that means is as I look at the unit circle and I look at the y coordinate of all of these points, that is the sine of that angle. So if I wanted to say, what is the sine of 60 degrees? The sine of 60 degrees is whatever the y coordinate is at 60 degrees. So the sine of 60 degrees is square root of 3 over 2, because square root of 3 over 2 is the y coordinate, and sine is connected with y. Likewise, if I wanted to know the cosine of 60 degrees, the cosine is connected to the x. We learned back in chapter 1 that cosine theta is equal to x over r, and because r is equal to 1, this would be x over 1, or in other words, just x. So that means that the cosine of 60 degrees is 1/2. It's that easy. All you have to do is grab the x or y value, depending on whether you're talking about cosine or talking about sine. Now, when it comes to secant, tangent, and cosecant and cotangent, things get a little bit different, but they're still not very difficult. So I want to try to walk through these as carefully and slowly as possible. Please, if I start moving too fast, take a deep breath and just try to kind of hang on. I'm going to try to go through these as methodically as possible. I'm sorry I'm not there in person. All right, so again, let's talk about this. We're saying that sine theta is equal to 1/2. So we're saying there is some angle where the y coordinate is positive 1/2. Well, let's look at our unit circle. Here the y coordinate is positive 1/2 at 30 degrees, which is pi over 6. And here, over here, our y coordinate is positive 1/2, which is at 150 degrees, or 5 pi over 6. So those are our two answers. We're supposed to answer in degrees, and we're supposed to answer in radians. So where is the y value? 1/2? Because this is how high 1/2 is. And so 1/2 happens at two spots. It happens right here in terms of the y value, and it happens right here in terms of the y value. So the answer to the question would then be theta is equal to 30 degrees and also 150 degrees. 30 degrees is the same thing as pi over 6, and 150 degrees is the same thing as 5 pi over 6. All right. Let's get rid of this. Don't need that anymore. Okay, let's look at the next one. Cosine theta is negative 1/2. Cosine is connected to x, so we're looking for any angles where the x coordinate is negative 1/2. So let's look at our unit circle. Okay, here the x coordinate is negative 1/2. So then, of course, down here directly below it, the x coordinate is negative 1/2. Out here it's positive 1/2, but that's not what we're looking for. So this is the angle we want, because at this angle right here, the x coordinate is negative 1/2. And at this angle right here, the x coordinate is negative 1/2. So we want the angle 120 and the angle 240, and what they are in radians. Okay, so the x coordinate is negative 1/2 at 120 and 240. And 120 is 2 pi over 3, and 240 is 4 pi over 3. All right. Now, those are the first two. They're the simplest, because every time we're thinking sine, we just look for the y coordinate. Every time we're thinking cosine, we're looking for the x coordinate. But now let's try tangent. Tangent's not any harder, it's just different. So the important things for us to realize is that we're really going to see three values when it comes to tangent. You're either going to see that tangent theta is equal to 0, tangent theta may be equal to 1 over square root of 3, tangent theta may equal 1, or maybe tangent theta equals square root of 3. Or it might be the negative versions of any of these. But this is a progression. This number is bigger than 0, this number is bigger than 1 over square root of 3, and this number is bigger than 1. These numbers get bigger as we go. So this is really the biggest that we'll see on the unit circle, this square root of 3. Now, if you grab a calculator and find out what is square root of 3, square root of 3 is something about 1.7 something, okay? And so therefore, this, like I said, is bigger than 1. So I start to remember, and I think about tangent theta being slope. And this is a slope with a number bigger than 1, except it's negative. So as I'm thinking about this, and I'm thinking about an x and y axis, that means I'm picturing a line that looks like this. It's got a steep negative slope. That's what this would have to be. Tangent theta is slope, and this is a steep negative slope. So then when I think about my unit circle, where do I see a steep negative slope? And I see it right here. That matches that description. This is a steep negative slope. And so therefore, the angle to right here, 120, and the angle all the way around to here, 300, represents that steep negative slope. And so those would be the two values. All right, so tangent theta is negative square root of 3. That's that steep negative slope. That happens at 120. Sorry, I don't really like to write in red. I'm going to switch that back. That's going to happen at 120 and at 300 degrees. And, of course, in radians, 120 is 2 pi over 3. And 300 degrees is 5 pi over 6. All right. Now let's talk cotangent. Hopefully tangent made sense. Tangent is slope. That's what we got to remember. Now, if nothing else, all you have to do for cotangent, maybe I shouldn't have erased that yet. All you have to do for cotangent is think cotangent is the reciprocal. All right? So now, if it's the reciprocal, I'm going to flip all of those values. So therefore, instead of this being the biggest one, that's now going to be the smallest. And instead of this being the smallest, outside of 0, that's now going to be the biggest. So it's in terms of like, I'm basically, and that's probably the worst explanation I could have possibly given, but what I'm trying to say is it's going to be the reciprocal of the slope, okay? So it's going to be different. This says cotangent theta is 1. Well, what is the reciprocal of 1? When you flip over 1, what do you get? 1. So I'm looking for a spot where the tangent is also 1. So where on the unit circle is my slope a nice, clean, positive 1? And the answer is right here at 45 degrees, but also down here at 225. There is a slope of 1, and so therefore a tangent of 1, and therefore also a cotangent of 1. All right, so those are the two numbers I'm going to use. I say I want to put in 45 degrees and 225 degrees. So therefore, I've got pi over 4 and 5 pi over 4. Awesome. Okay. Next, we've got secant. Now again, secant is a reciprocal. Secant is a reciprocal function of cosine. So when I see square root of 2, I have to not think square root of 2. I got to think the reciprocal of that. So what is the reciprocal of the square root of 2? Well, square root of 2 flipped would be 1 over the square root of 2, which is also known as the square root of 2 over 2. And we saw that a lot. We saw that a lot on our... So then you think about it. You think secant is connected to cosine. Cosine is x. So I'm looking for where my x value will be the reciprocal of square root of 2, which is square root of 2 over 2. So I'm looking for my x value to equal that. Here my x value equals that, and down here my x value equals that. Because I'm looking for square root of 2 over 2. And remember, square root of 2 over 2 is also, as I said, equal to 1 over square root of 2. So secant, square root of 2, I take this and I flip it. When I flip it, I get 1 over the square root of 2, which is this also, square root of 2 over 2. Secant makes me think cosine, makes me think x, so I'm looking for where my x coordinate is this. So therefore that happens here and down here. So that happens at 45 degrees and at 315 degrees. So those are my two answers. 45 degrees and 315 degrees. 45 degrees is the same thing as pi over 4. 315 degrees is the same thing as 7 pi over 4. And lastly, let's look at this last one. We've got cosecant is negative 2 over square root of 3. Again, I should immediately be thinking this is a reciprocal function of sine, so I need to think about the reciprocal of this right here. And the reciprocal of that would be negative square root of 3 over 2. So I want a spot where sine theta is equal to that. Or in other words, y is equal to that. So I'm looking for y to equal negative square root of 3 over 2. So let's look at our unit circle. Where is y negative? Well, y is negative everywhere down here. And where's y negative square root of 3 over 2? Well, that's right here at 240 and over here at 300. So those are the two angles I want. I want the angle 240 and 300. or the angles. And 240 is the same thing as, what, 4 pi over 3? And 300 is the same thing as 5 pi over 3. All right. Now let's look at the second part, okay? The second part is no harder. It's just backwards to the first part. The first part, we had the output and we were trying to get the angle. Now, in the second part, we have the angle and we want the output. This is actually way easier, and I want to show you. Some people I saw in yesterday's class, they wrote things like this. They wrote sine of 30 degrees, or maybe they wrote just 30 degrees, because they saw that pi over 6. They knew that pi over 6 was 30 degrees. But that's not what I'm asking. I'm asking what actually is the sine of pi over 6. When you put pi over 6, the angle pi over 6, into the function sine, what output do you get? And the answer is you get the y coordinate. Sine is y. So you get the y coordinate at this angle. So let's look at the unit circle. Here's pi over 6. So the sine of pi over 6 is the y coordinate at that angle. 1/2. It's that easy. Sine of pi over 6 is 1/2. Next, cosine of 330. Cosine is the x, or the x coordinate. We just need to look at 330. Let's look at 330 on our unit circle and say 330 is right here. Okay, what is the x coordinate? Right there, square root of 3 over 2. So cosine of 330 is square root of 3 over 2. Now we get to tangent. Now when we think tangent, we got to remember slope. Tangent is slope. So tangent of pi over 4. Let's find pi over 4 on the unit circle. It's right here. That's our 45 degrees. That's the easiest one. We said the slope of 45 degrees was always just positive 1. So that's simple. The answer is positive 1. All right. Next, the cotangent of 315. Now, cotangent gets a little bit trickier. We want to look at the slope, but then we're going to flip it. So let's look at 315 and see where that's at. 315 is right here. So what is the slope of that number? Or what is the slope of that line? Well, it's one of the 45-degree angles. It's just the one that's going down in the fourth quadrant. So that's got a slope of -1. All right? And what's the reciprocal of -1? -1. So that's really easy. Not all the cotangents will be that easy. I notice I've actually got some really simple ones on here, and those are kind of lame. We'll make those, change up the question on those so it's not the same routine on each one of those. Those are lame. All right. Secant of pi over 3. All right. Remember, secant is the reciprocal of cosine. So all I need to do is go to pi over 3, look for my x, and flip it. Okay. So let's look at the unit circle. Pi over 3 is right here. Here is my x. Flip the x value. So instead of 1/2, I would write 2. That's the reciprocal of 1/2. All right, moving on. Cosecant is 240 degrees. Cosecant is 240 degrees. I'm sorry, cosecant of 240 degrees, not is. Cosecant of 240. Cosecant is the reciprocal of sine. So I'm going to go to 240, look at the y for sine, and then flip it. So let's look at the unit circle. Here's 240 degrees. Here's my y coordinate, negative square root of 3 over 2. I take that and flip it. And go, so therefore, cosecant will be -2 over square root of 3. Next, sine of 2 pi over 3. Sine is the y coordinate at that angle. So go to the unit circle. 2 pi over 3 is right here. The sine, or y value at that angle, is square root of 3 over 2. That's easy enough. Square root of 3 over 2. Next, cosine of 360. Cosine is the x. Go to 360 degrees, which is right here, and tell me what the x coordinate is. It's 1. That's simple enough. All right, next, cotangent of 5 pi over 4. Again, this one is lame, and I'm sorry. I definitely should have made some changes, and I'm realizing that now as I look at the sheet. I should have made some changes and made this better, but I didn't, and I apologize. All right, but either way, 5 pi over 4. All you have to do is go to 5 pi over 4, which is right here, and tell me what is the slope at that point. The slope is 1. And what's the reciprocal of 1? 1. That's why that's so lame. It's so easy. Okay? So, cotangent of 5 pi over 4 is 1. Sorry, Siri's talking to me again. Awesome. And lastly, we have tangent of 495. Now, I tried to be a little bit tricky with this one and throw something over 360, but all you have to do is go, well, if I subtract 360, I'll find a coterminal angle, and that gives me 135. So it's going to have the same as the tangent of 135. So, tangent is slope. So let's go to 135. 135 is right here. The slope of that line is -1. So therefore, the tangent of 495 is -1. Now, my guess is, now that you guys kind of see this done and see it explained, I'm guessing you could do it a lot better. So I'm going to have you work on another sheet right now, and then we'll go over the answers to that in just a little bit. Good luck.